Okay, the last problem we did was in the vertical direction. This problem is going to be in the horizontal direction, but the concept is still the same. The work that is done on the object will change its kinetic energy. So here we have a problem where Bonnie Blair of the United States sets a world record in speed skating when she skated 500 meters with an average speed of 12.92 meters per second. Suppose she crossed the finish line at this speed, then work was done on her by friction over a certain distance. That total amount of work was negative 2,830 joules. Why negative? Because it was in the opposite direction of her motion. Question is, what would her kinetic energy be after that amount of work was done on her? So a picture is never a bad thing. Here's the finish line. She has an amount of kinetic energy to start. We can find that amount of kinetic energy with the kinetic energy formula, which is 1/2 mv squared. We know her mass, we know the velocity she crossed the finish line with, so we know this initial amount of kinetic energy. She then stands up, no longer part of the race, and she allows friction. That's supposed to be a straight line. Not so good at that. She allows friction to do work on her. The amount of work she allows it to do is negative 2,830 joules. Question is, what is the kinetic energy final that she's going to have out here? Okay, so the concept is still the same as the last problem. The work done on her will change her kinetic energy. In the last problem, we had to solve for the work. We had to figure out, well, what was the force being applied for what distance? In this problem, the work is given to us. It is negative 2,830 joules. The initial kinetic energy we can find anytime we have change in its final minus initial. We can find the initial kinetic energy with our 1/2 mv squared. Therefore, then solve for our final kinetic energy in this work kinetic energy equality. So I have 1/2, her mass is 55, her velocity is 12.92. When I calculate that, her initial kinetic energy is 4,590.476 joules. This is not my final answer, so I do not want to round it. I know that this is negative 2,830 joules, so I can solve for the final kinetic energy by adding this amount to the other side, and my final kinetic energy then will equal 1,760 joules with significant figures. What if, now this is not the question, but what if this was the question? How fast is she going after this amount of work has been done? Could we solve that? Answer, why yes. Kinetic energy, final, would be 1/2 mv squared. If we know her mass is 55 and we know that her kinetic energy is 1760, we can solve for the velocity and then make sure you square root to get the final velocity when her kinetic energy is 1760. I do want to tell you that there is one typo on this worksheet, and that one typo is in problem number 5. The answer should be negative 2.14 joules, not 2.16 joules. Good luck. I'll see you Friday.